life cycle cost reduction potential of nearly zero energy buildings. So the first session is dealing about lessons learned and findings of the project. And the second session will be about the CRAVEzero pin board. So the CRAVEzero pin board is an interactive framework providing interactive free tools for nearly zero energy buildings. And we will guide you through some of the main functionalities of the pin board. About the project in general, so CRAVEzero's primary goal is to identify and eliminate the extra costs of NSEPs related to processes and technologies. The scope is the whole life cycle, and to promote innovative business models taking account the cost effectiveness of all stakeholders. So it's a multi-stakeholder perspective. The first session, as I said before, is dealing about lessons learned from nearly zero energy buildings all over Europe. So the project itself is conducted by IE Intec as a coordinator together with Euroc Research, Fraunhofer ISE, industry partners from Bouygues Construction, ATP Sustain, Skanska, 3E, Moretti, Köhler and Mainzer, among others who conducted this project and who have been building nearly zero energy buildings all over Europe. So what can we learn from nearly zero energy buildings? What are the fundamentals of NSEP design? So before we start, usually NSEP is a technical concept. So it usually deals with reducing your energy demand with heating, cooling, ventilation, lighting, plug loads, and auxiliary energy. First, it's a common understanding that you have to set optimal goals. You have to set very tight goals for the buildings. Then optimize the envelope quality. Once again, please, for all the participants, please always mute your microphones during the meeting. So this will not be done automatically. Moment, I just... Excuse me, there is somebody. Okay, so it's muted. Sorry for that. So, and then optimize the envelope or the passive measures at the first step. Then think about efficient energy building services, optimize operation, deal with user behavior, and then let's say the first steps are the reduction of the demand, and then use renewables to match the production and the demand. What we are dealing in the CRAVEzero project is more or less not only NSEPs as a technical concept, but NSEPs as a multidisciplinary life cycle approach. So what we're dealing is, what can you do from the political decision, urban planning, construction, operation, maintenance, and renovation phase? Basically, there are cumulative costs and energy demand of each building during those phases. So we look at the whole phase. We look at possible actions in each phase to reduce costs or energy, and we're looking at the key actors for each phase. So when we look at the standard building, usually the costs and the energy demand of the building accumulates over the whole life cycle. Usually for a nearly zero energy or plus energy building, is that you invest a little bit more in the planning phase, also in the political decision, urban planning phase, ideally, also sometimes in the construction phase, but it pays off over the life cycle. What we're trying to do in CRAVEzero, this is the CRAVEzero approach, we're looking at the cost reduction potential in each phase. So really starting with the political decision till the renovation phase. So what are the cost reduction potentials in technologies and processes in all the phases? And we're looking at the key actors. So we're looking at all the different actors all over the life cycle. And
okay, good, thank you. Cheers.
Basically, once again, to all the participants who are not unmuting their camera, please do that. Turn off your camera and mute your microphone, please. So the key actors basically have a different perspective on the life cycle. So it deals with municipalities, authorities, the whole society, investors, planners, construction companies, facility managers that have a different perspective on NSEPs and have different goals when it comes to an NSEP. So what we're doing in the project basically is looking for cost reduction technologies in processes, technologies, and business models. So we compare the fundamentals of NZEP design by reducing the demand and meeting the building's energy needs by efficient building services and on-site renewable energy systems with the CRAVEzero methodology. And the CRAVEzero methodology is an 8-step approach. The first one is to define energy cost related project goals, define actions to reach those goals, track them through the life cycle, create win-win situation for all stakeholders. This is dealing with processes. Select optimal NZEP technical solution sets, do life cycle cost analysis and variance, quantify co-benefits. This is more the technology part of an NZEP. Learn from front runners to avoid pitfalls and bottlenecks, and bring together all the previous steps in a business case for NZEP, which deals with new business models for NZEPs. What we are doing is, usually there are extra costs for high quality NZEP buildings. So an European average standards is that they have per net floor area, they have additional costs, usually when it comes to investment of those buildings. We're dealing about optimal technical solution sets. We try to reduce costs on the one side. On construction costs, we try to reduce costs by optimized processes, time savings, and to reduce costs by reducing of embedded failure costs of NZEPs to kind of reach a building that's already in the investment phase cheaper than usual NZEPs. And when we take the whole life cycle perspective of a building, so when we look at the time dimension, we also try to reduce consumption costs, operating maintenance costs, and reduce the invest for replacement and renovation. And these are numbers that we found out during the project. So what are the potentials that we see in analyzed CRAVEzero case studies? What needs to be done also to reach those numbers? And how to quantify co-benefits that are come along with nearly zero, net zero and plus energy buildings. So this is the whole perspective of the project. The main results is a database of benchmarking of actual NZEP lifecycle costs and technologies to give more planning security and trust in NZEPs, KPIs and parametric lifecycle models of zero energy buildings to optimize processes, optimized NZEP processes over the whole life cycle for time saving and a reduction of embedded failure costs of NZEPs, cost reduction potentials for technical solution sets. So we're not looking at a single technology, but the combination of technologies, NZEP business models with a goal for market uptake and financing, and the interactive CRAVEzero pinboard and prototypical implementations, also with the goal for market uptake. All of the results can be found on the website of CRAVEzero. So the website address is CRAVEzero.eu. The pinboard with the interactive tools can be found on the pinboard.CRAVEzero.eu. We worked in 24 reports and about 1,600 pages in 24 reports with background information that can be found on the website, and pinboard tools that are available freely for everyone to use. The pinboard itself, which we'll be dealing in the second session, has tools ranging from a business model canvas, interactive process maps, a lifecycle tool free to use, lifecycle cost benchmarks, an NZEP revenue stream calculation tool, lifecycle cost tracker, among others. Also, our project partners implemented what we have learned from the CRAVEzero project and the CRAVEzero pinboard in ongoing NZEP projects that are under the planning and construction phase at the moment. Here are some links about the CRAVEzero website and the pinboard. And now I would like to forward to our first presenter, Ms. Roberta Pernetti from Europe Research.
Good morning, and thank you, Tobias, for the introduction. Now I have the control of the presentation. So basically, as introduced by Tobias, the aim of the project CRAVEzero is to identify all the extra costs during the whole life cycle of an NZEP in order to define strategic solutions to cut off and to reduce them. And this is It seems that it doesn't work. Presentation. Okay, now it works. Okay. So we noticed that basically one of the main barriers to the uptake of nearly net zero energy building across Europe was that usually the business models, the business plan, focus on the initial investment for building a new NZ. So all the extra costs during the initial investment can undermining the willingness of building a new NZ. Therefore, in the project proposal, we tried to introduce also the time dimension, and also in the project implementation, we tried to introduce as much as possible also the time dimension, considering in the business plan also the further phases like operation, maintenance, also the renovation, the end of life of a building. So the life cycle cost analysis represent the key base approach of the project. Although there are already some standard procedures available from ISO standards and other references across Europe, such procedures are not so, for the life cycle cost calculation, such procedures are not so, let me say, operative and usually don't bring to comparable results. In fact, the life cycle cost approach is used by some design firms and construction companies, but still a lack of comparability across all the indicators, and there is a lack of a shared set of benchmarks and references that can really bring to compare the results of different projects. And also the other barriers of application is the fact that there are several uncertainties in the calculation due to the time frame and also to the difficulty to really predict what will happen to a building. So what we tried to do within CRAVEzero is starting from what is already available to define a structured methodology for allowing the calculation of comparable results and benchmarks. So as I said before, we started from already existing references, so the ISO standard 15686 and the code for measurement cost planning for identifying the breakdown of the building elements, and the phases are taken from the ISO standard, and we try to break down for each phase the cost and the references to enable a standard and shared calculation. So we also tried to introduce some normalization factors in order to enable the comparability of the key performance indicators evaluated through the CRAVEzero methodology. So basically, we introduced, I missed the references in this slide. I will integrate while we share the document participants. But basically, we integrated the construction cost.
Bevor wir das vergessen zum Reden, Philipp, schaust du kurz noch das Mail, was ich da gegeben habe?
Sorry, I see a mouse. So we integrate the construction cost index, and we normalize the results
vom Preis,
energy
die abgelegt haben wir grundsätzlich bei der Prüfung elektrotechnische Sicherheitsvorschriften.
Sorry, Roberta, I will just take over the control to mute some of the participants.
Yes, please. It's difficult to speak with the
yes, one moment.
No problem.
I think, sorry for the inconvenience, but
No
I think
problem.
now
Absolutely
all of the
no
participants are
problem.
muted, and I will give back
Thank you.
the control to you in a second.
And so, as I said before, we defined an approach to normalize the main parameters that can affect the comparability of the indicators across Europe. So basically, we normalize according to the climate condition using the heating degree days, the energy cost using the average energy prices from Eurostat. And also, we consider the gross surface as a reference for the normalization. Last word within the slide is the definition of the time frame that basically we decided to consider as 40 years. The ISO standard allow for taking a time interval, a maximum time interval of 100 years, but of course it is important to find the right balance between the uncertainty of the cost and of the calculation. So 100 years is a very long time, and also the availability of information. Therefore, we selected 40 years as a reference, also considering the observation periods for the different building systems. All these considerations and calculations that we did for life cycle costs are included in the so-called CRAVEzero and ZEB spreadsheet. That is a structured, let me say, it seems like an energy certification and energy labeling. Also, it's a structured document when you can find all the information that we analyzed within CRAVEzero. Both for the investment and for the life cycle, identifying which is the share of the different phases and of the different building elements within the overall cost of the project. So this is a very screen of all the costs within a project, and is a very interesting document to be used as a reference for presenting a case study. Then what we did within CRAVEzero, as Tobias introduced before, is to analyze 11 case studies that are composed by, in total, 12 buildings. We analyzed these front-runner case studies for which we have a very huge availability of data, since the project partners have been involved or in the design or in the construction phase, but basically they have the availability of very detailed information about all the costs during the design and the construction phase. We analyze them with the life cycle cost tool that I will present in the second sessions, and we are able to identify a set of indicators, as I showed before in the NZEB spreadsheet. Basically, we tried as much as possible to identify some preliminary benchmark. Of course, defining benchmarks with 12 buildings across Europe, we cannot say that they are shared benchmark, but it's a starting point, and we try to define some indicators and some reference values in order to give a reference to the designers. Within this framework, it is possible to further collect data about buildings and to fine-tune the benchmarks, increasing their representativeness. And so basically here I presented some of the charts that are included in the report. If you are more interested, you can access through the CRAVEzero website to the complete report that is deliverable 2.2. Life cycle cost of NZEB case studies. And basically here I showed which is the design cost and which is and which are the investment and maintenance costs per square meter. So it is possible to compare how the design costs have an impact on the overall life cycle cost, and here also the share of investment and maintenance. So to conclude my presentation, basically the key results that are given by this first activity of definition of life cycle cost approach. Basically, we define a tool for the life cycle cost assessment that implemented a methodology that is operative and is easily replicable, where you have all the boundary condition and all the information to make a calculation that enable a comparison with the benchmark that I provided before. There is the structure of the CRAVEzero and ZEB spreadsheet with the definition with the set of all the KPIs that in our view and that from the activities of the project are considered as representative. And we have some preliminary benchmarks coming from these exemplary case studies that are spread across Europe and residential building. So as I said before, it's a starting point for defining a more accurate benchmarks. So later I will present a simplified and online version of the lifecycle cost tool that is available on the Pinboard. And yeah, now I leave the floor to my former colleague, Jens. Tobias, if you want to take back the control.
Yes, thank you, Roberta. So just a reminder to all the participants, I think now everybody has muted their microphones, so thank you for that. Please, if you have any questions to Roberta and her presentation and all the other presenters, please use the chat function. I will now pass on the control to our colleague Jens Glöckler from RTP Sustain, who will talk to you about NZEB lifecycle processes.
So thank you, Tobias. Hope you can hear me all. Yeah.
Yes.
Good morning to everyone from Munich. Well, as Tobias said, I will explain a little bit what we did in the tool of the lifecycle processes. As the focus of nearly zero energy buildings is the whole life cycle, we developed also the necessary lifecycle processes. And we started with the approach in a building design, first of all. So here the influence on life cycle cost is the highest at the beginning of a building project. We also found, of course, different actors as stakeholders in the process, which you can see here on the top. And the aim was to optimize the process for an NZEB quality building with possible cost savings throughout the life cycle. So one important aspect in the development of actions and tools was the awareness of the perspective of the stakeholders with the different time expectancy, which I can show you right away. So that this is one example of the case studies we developed the tools for, and here you see the process map and the connecting tools, which are like the process map is a central tool, and it gives a good overview and combines in a map all the other CRAVEzero tools and relationships. And from here you can click directly in the action items or tools to move there. So in our development process, we not only created a map and structure, we also created a possibility to extract single actions to create an individual project working list. And this tool is the lifecycle project management, which will be shown later on. So as as I said, we started with design or the building design, and we found, of course, there are a lot of possibilities also ahead of this, of a single building design, which is political decisions and the urban planning phase. So we also developed actions for these stakeholders. And as you see here in the overview, the actions and tools have depending on the awareness of the perspectives of the stakeholders with a different time expectancy. So as you may see on the bottom, society, like represented by politics and municipalities, has the longest perspective. And these are the first in the process to influence, of course. So we show for them also how to influence in the projects. One example here is in the case, well, like out of the case study of the city of Vienna, one part of the city, a new city district, Aspern, and the municipality of Vienna developed out of a national strategy, a regional strategy, as you can see here, for CO2 emissions, a local strategy, and this local strategy for the city district of Aspern was to create all buildings there as climate neutral buildings, like a climate neutral district. For all buildings, there was they needed to have an in-house power generation, and also there was a mobility plan to give the best starting point for the building designs. So, and therefore, our case study was under these regulations. Okay, so what did we learn about the whole process map? As I said, the process map is the connecting element between the tools. The process map was created to show the correlations and to understand the complexity. And all actions have been described in detail and are linked in the other tools. So as all chances have also their obstacles, we decided to also show the bottlenecks and how to avoid them, of course. This will be shown later on as well. So the process map shows the complexity not only of interactions of stakeholders and to act in the right phase, but also the interdependency of actions. Last but not least, the actions also show possibilities, co-benefits, and their impact on the life cycle costs, of course. So that was a short sum up of the development of the life cycle processes. Thank you.
Okay, thank you, Jens, for the processes. As you know, the process map that Jens was talking about will be shown in the second session of the webinar. So we can see the whole life cycle process of NCEP's bottleneck actions. Again, a reminder to mute your microphones and ask questions to the presenter when you have them in the chat function. So now the next presenter is Mr. Benjamin Köhler from Fraunhofer ISE. He will talk about NCEP technologies and NCEP solution sets. Benjamin, I will pass you the control in a minute.
Yeah, perfect. I already start. Good morning from Freiburg. Warm welcome to our webinar today. And in the next couple of minutes, I will talk about cost reduction potentials of NCEP technologies. I divided the presentation in 3 parts, mainly. Shortly introduce the goals and approach, talk about the main results, and also a short conclusion and outlook. What did we do in this part of the project? First of all, we identified the main technologies needed for realizing nearly zero energy buildings. And we assessed the current costs and cost reduction potentials until 2050 for all identified technologies which are currently installed and might be important in the future. Then we assess the building design itself, and there we focused on the identification of promising passive approaches to minimize the energy demand of the buildings and assess the impact on the energy demand itself and also the life cycle costs. From that, and also from the work which has been done in another work package, which will be introduced later on by Mr. David Venus, we identified low life cycle cost and low emission technology sets, bringing together different passive approaches and active technologies and visualize those sets. Last but not least, and a bit like separated from the other parts, is that we assess the energy flexibility of buildings. Therefore, we identified currently discussed and used KPIs for the flexibility of buildings and assessed the flexibility and also impact on the grid of different sets, mainly focusing on PV and battery storage. Just shortly, what I want to show you here is that for almost all technologies needed for nearly zero energy buildings, there's still quite a high cost reduction potentials in the coming years, depending on the market development or the assumed market development until 2050. And what you can see is that mainly relatively new technologies like battery storages, but also heat pumps or different new ventilation systems. There's quite a high cost reduction potentials for already established technologies like different boilers. The cost reduction is relatively low or assumed due to the assumed market development. So the reduction is for several technologies above 50% compared to today's values. The passive approaches we assessed is the building orientation, the changes in the window to wall ratio, additional fixed and controlled shading, daylighting control and natural free ventilation, using the ambient air temperature as the control value. We assessed the approaches in 3 different climate regions: one cold region, northern Sweden, moderate region or moderate climate here in southwest Germany, and a hot climate region, Palermo in Sicily. And to assess the different approaches, we did a detailed building simulation. And there we used one of the case study buildings, which is located in southwestern Germany, as the basis. The results are summarized here. For Germany, we identified energy demand reduction potential of around 11%, mainly in the heating energy demand due to an optimal building orientation, and in this case also an increase in the window to wall ratio. For the lighting energy demand, as we assumed already highly efficient lighting installed in the buildings, the absolute and also the relative reduction is relatively low, as the share of lighting in the overall energy demand is low. For northern Sweden, the effects are a bit lower. The energy reduction potentially is only about 2%, which is mainly due to the high heating demand and the low additional solar gains you can achieve by optimizing the building itself during wintertime, during the heating season. And the highest absolute and relative effects were observed in southern Italy, because optimizing the building orientation, window to wall ratio and shading system has a very, very high effect on the cooling loads and also the cooling energy demand. Next up, we identified optimal technology sets, like the low LCC and low emission technology set. What we saw there is that the main factors on the life cycle costs and the emissions are a good thermal envelope. But what was very interesting is that non-technical parameters were actually the ones which had the highest influence. It's on the one hand the climate, but also the user behavior. In all variants with the low life cycle cost and low emissions, usually domestic hot water was the dominating energy demand. And what we observed is that those variants had only few technical installations, so they could be considered as low-tech concepts. Here is a summary of the factors we assessed in a parametric analysis. So it's the envelope quality, compactness, different set points, cooling systems, renewables, ventilation systems. I don't want to go into detail here because this will be described later on anyway. What we saw as here is an example, a case study building in France from our partner Bouygues Construction. On the left side, you see the base case. Here you have mechanical ventilation with heat recovery, with additional heating functions in the ventilation system, and it's connected to a district heating grid. And the variant with the lowest life cycle cost you can see on the right side, it's just window ventilation in this case, and also not connection to the district heating grid, but to biomass in this case. Concerning flexibility, we assess different KPIs, mainly, or actually 4 KPIs we focused on: self-sufficiency and autarky rate. It's the grid support coefficient, GSC, which was developed at Fraunhofer ISE. And we assessed the smart readiness based on the definition of the smart readiness indicator on European level. The status of the discussion was what we saw here is that the goal of your flexibility very much influences the technologies which have to be installed. You can see here on the top the self-consumption and feed-in of a building with PV and battery storages. Like there are different variants with different PV sizes and battery sizes. And in the bottom, you can see the autarky rate. And what you can see is, like, if you want to focus on self-consumption, for example, variant 3 leads to very good results. That means that the PV system in this case is relatively small, but you have a battery installed. A small PV system, on the other hand, leads to low autarky rates. So it's very important to define what you want to achieve in the very beginning and early, because this very much influences what has to be installed in the end. As a summary, like what we saw is that for most relevant technologies, there's still a large cost reduction potential until 2050. And if you consider the whole life cycle of a building, you can also consider those cost reduction potentials for future investments or replacements of the technical installations. Concerning the technology sets, passive approaches and the minimization of the energy demand are very, very important to realize nearly zero energy buildings, plus the renewables on site, of course. What we saw is that low-tech variants lead to the best results with respect to costs and CO2 emissions. So if you consider both factors. And what we also saw is that nearly zero energy buildings are possible even with lower cost than a standard building in the different regions we assessed. And as I already said, concerning the flexibility, the addressed KPI and your goal strongly affects the needed technologies, as shown the autarky versus self-consumption, but also the building perspective versus the energy system perspective very much influences what you have to install to achieve your goal. Just shortly, what we are currently working on is that we provide the collected costs for the different technologies and also for the cost reduction potentials until 2050 in a cost database, which will be implemented in the CRAVEzero pinboard, which is introduced in a couple of minutes. We are currently working on the finalization, so it's not available yet, but will be there in a few days or weeks. So that's it from my side. Thank you for your attention. And as Mr. Weiss said, if there are any questions, please write them in the chat.
Thank you, Benjamin, for your presentation. The next presentation is about NSAP business models, and Mr. Arnulf Dinkel from Fraunhofer ISE will be talking about business models in the next couple of minutes. So Arnulf, I will give you the word and I will take over the presentation from you.
Yes, thank you very much. Welcome to this session. My name is Arnulf Dinkel. I'm from Fraunhofer Institute for Solar Energy Systems in Germany, like Benjamin, and I would like to inform you about our actions dealing with the business models. Next. So, for the introduction, I would like to present our goals. So we wanted to find comprehensive win-win business models during this action, of course, and to address all the stakeholders who are involved. So I saw we are a lot of people here in the sessions, and most of you might be stakeholders, so you might be interested in that. We want also to increase confidence and reliability of the business models and of the businesses everybody does within this context, and of course robust models also, not these fancy ones, but models who might work in this context. And of course we wanted to address the uncertainties and obstacles. Next, please. So the goal was to lower the cost for all this, and we implemented and we found some around 70 plus models, and we want to present them in the second session, what to deal with them. So we have a big storage now of business models within this context. Next, please. And I want to show what we did and what you can do. So we started to find typologies of business models and to think about how can we compare and find them. So this was our first step. You can find all the documents also in the web, of course. So, and we decided to take the Osterwalder model, business model canvas. So this is a very common methodology to describe businesses and to compare it a little bit. And the whole work is based on this tool. It is very helpful to describe all these models and to compare and to deal with them. In a next step, we found the existing business models within our partners within the project, of course. And we described them and found out what the partners in the project did so far and how they deal with it. So starting from that, we enlarged the database of the business models, and what we found in the web within the EU, the partners gave some new ideas. And next, we created a guideline how to create and how to use all these tools and to get familiar with these business models and how to work with them. And what we would like to present in the next session is our online tool. It's the CRAVEzero pinboard, and how you can create or deal with the existing ones and create new business models. So this was the circle, and you can follow them, of course, and find the documents in the web. Next, please. The results is that we had a typology, and we can describe these business models in a comparable way. So via this Osterwalder canvas, and I would motivate everybody who wants to deal with it to get familiar with it. It's very helpful. We had a description of all the elements within this Osterwalder business model, and at the core of it is the value proposition. It's in the middle, and everything starts from the proposition you give to the client, of course. That's very important. And starting from there, you can look what you need to go into the business. And we found out that competence and know-how and the customer relationship, these are the core elements of a business model which you should use or which you should develop to get a very good business on that. Next one. So you saw these curves and the blue dots in it. These are the business models we found. So you can see most of them are around planning and construction phases, and rarely in the beginning and political phases, decision phases, or at the end, recycling. So there's a big potential to find new markets within all the life cycle, and you can stick to it and find your place with it, or to enlarge your ideas. And you have an opportunity to check what there is and to make it better, or to add something to your businesses and to find a place in the market for that. And that's the reason why we created a database. You can stick on it and you can look at it, use it, or make it better. So next. We've described these models like this in a one-pager, so there are only some headlines, but you can find it in our documents. There's a short description on that. The main topics are there. There are strengths and key factors of it, and you can see or easily find where it is allocated on the life cycle of models. Next one. So this is an example of one model. So it's dealing with the residential sector. We have numbers. This is business model number 10. The value proposition here is to guarantee quality and energy consumption. And the nice thing here with this model is they guarantee it for 20 or 30 years. So that's very important, and it's a very nice business model, because very often you don't get these guarantees for that long time. So, and that's the main core of it, to guarantee the building performance and the operation costs. And therefore you need widespread competences. And also it's helpful if you learn from your own projects and make them better and downscale them or make them bigger. So nice example for that. Next, please. We also try to create new ones. So this one, which might be interesting, is one-stop shop for waste. So the value proposition there is to solve all the problems around waste during the whole life cycle. So it might be interesting to create a new company or to implement it into your company to deal with waste and cover the problems around the materials from new buildings, refurbishment, and so on. And it will help to reduce waste and waste cost around that. Might be interesting for somebody who will deal with that, for example. Next one. And as a result, we have this pinboard where you can play around with all these found business models, and you can find also the strategies and the methods to describe new business models within our documents in the deliverables. And a nice option is our pinboard, which we will present in the second session, to play around with it and to print it out and to use it within your own company. Next, please. So for the conclusion, we think that there is a potential for new business models for all stakeholders. So whatever you're doing, you will find something and you can make your own business better or add something. And we found also out that the value proposition must be clear and useful for your client. So that's the real core of it, and it must be very well described. And sometimes if we screen the market, we don't really find the idea of the business of someone. So please be careful about that. And the business models, they are always valuable for different stakeholders, of course. It's not only one stakeholder, one business models, so you can change it. And they can be upgraded and combined, and you can find new markets, of course. What we also found out that the models might be useful all over the EU, so there might be some regional markets, but most of them are valuable everywhere, so you can use it everywhere. And I said it before, the way and the relevance to strengthen the relationship to the client is very important and crucial. So most of the partners we talked and we found out that they have a strong relationship to them. And our pinboard offers different options to filter and find information about this. And I hope we can motivate you to stick to new business models, to find out about business and to use our tools on the web. So thank you very much.
Okay, thank you very much, Arnulf. Once again, a reminder to all the participants, please use the chat function to write questions to the presenters. We now, in our session, this is the last presentation before our second session, the CRAVEzero Pinboard starts. This is Mr. David Venus from IE Intech, and he will talk about a life cycle cost reduction of nearly zero energy buildings and results of parametric calculations. So David, I will give you the control in a moment.
Thank you very much, Tobias. Welcome also from my side. As mentioned by Tobias, I'm going to show you some results of the parametric calculations which were performed within the CRAVEzero project. And the idea of the parametric calculations was that we are going to investigate all possible designs of a building, and not only the designs which can be explored manually. That means there's a difference between the different design options and the different parameters. And what we wanted to do is to automate the calculations and thereby investigate all possible designs. And to be able to do that, it is sure that we need a calculation method which is able to deal with this amount of different variants in a manageable amount of time. So in the CRAVEzero project, the parametric calculations are based on the one hand on the passive house planning package, the PHPP, which is used for the energy calculation. And on the other hand, we are using the CRAVEzero lifecycle cost tool for calculating the lifecycle costs. And since both tools are Excel-based tools, we were able to automate the calculations by using macros. So the investigated buildings were presented before, shown before, and what I would like to highlight is the investigated parameters. And the parameters can be divided into 4 main categories, let's say. First of all, we have architectural and urban planning parameters like the window area compactness, or also the location, climate, and the sea level. We have financial and economical parameters like the credit period, the CO2 follow-up costs, for example, or also the different energy price increases. We investigated also different technologies as presented before, and also set the focus on different user behavior, where we varied, for example, the room temperature or the domestic hot water demand. So in total, more than 360,000 variants were defined for the buildings and calculated. And some of the findings I will show now. This is a general overview of the calculation results for some of the case studies. Here, there's a comparison between the life cycle costs on the y-axis and the CO2 emissions on the x-axis. And what we can see is that the difference between the highest and the lowest CO2 emissions is very high. It's the factor 8. On the other hand, the difference between the highest and lowest life cycle cost is much lower. So it's just a factor of 1.5. That means also that, for example, much lower CO2 emissions can be achieved with the same or with similar life cycle costs. Further results I want to show now using one of the case studies. It's the case study Valagard. And as expected, different parameter combinations for sure lead to different results. And two examples are shown here. First of all, we have a reference scenario which achieves, let's say, financing costs and life cycle costs, which shows some optimization potential, let's say. And the other scenario, which is shown here, is called the CRAVEzero scenario, which achieves not the lowest financing costs, but in fact the lowest life cycle costs and the CO2 emissions. That means that we identified cost reduction potential by performing the parametric calculations. Those cost reduction potentials are also shown here on the left side, where we can see the specific costs of the building over all phases of the case study. And what we can see is that compared to an average scenario, cost reductions are possible in the range of 9 to 14% per phase. On the other hand, we can also see that there is also an increase possible, also compared to the average scenario, and the increase is in a range of 6 to 17%. So to break it down to a few more numbers, for the case study, what we have seen is that the difference between the highest and the lowest financial cost, for example, is 400 euro per square meter, or 20%. The difference between the highest and lowest life cycle costs is about 500 euro per square meter, or 15%. And the difference for the balanced CO2 emissions is, here in this case, 38 kilogram per square meter in year, or these are 73%. And for the primary energy demand, it's up to 160 kilowatt hours per square meter in year, the difference, which are 66%. Below, we can also find another result which shows the influence of different parameters on the key performance indicators. And what we can see here is also what we heard from Benjamin before, that, for example, the sea level or the location has a very high influence on the key performance indicator, but also the envelope quality. Additionally, also the co-benefits were analyzed, and Tobias will show you a few slides to the co-benefits.
Thank you, David. Just a couple of slides concerning the co-benefits. So very early on in the project, we realized that it's also important not to only look at technology options or different business models, but also to try to quantify co-benefits. And these are usually not so easy to quantify. So different stakeholders throughout the life cycle also have not only energy-related benefits concerning by NSEPs, but also other benefits. So dealing with marketability, lettability, value development, rental income, or improved comfort, and also co-benefits like extended durability of components, architectural quality, image, next to energy saving, user satisfaction, climate protection, and energy autonomy, which different stakeholders have different interests in. And some of those co-benefits are more easy to quantify, and some are more difficult to quantify, but they have a certain relevance also for the business case when we say about non-energy related benefits. And what we did quite early in the project is, next to our life cycle cost calculation, is that when you want to make a business case out of it, it's not only about the life cycle costs, but also about the life cycle incomes and about the co-benefits you can generate with your NCEP. So we tried to quantify different co-benefits. When we looked at the life cycle cost calculation from an investor's perspective, usually it's a higher initial investment that pays off, and very often with NCEPs or buildings that have a higher standard, they have a payback of approximately 15 to 20 years. What we try to do is, by quantifying those co-benefits, is when we looked at the different CRAVEzero case studies, can we think, especially as office buildings, so what happens if there is a higher comfort in the building and there are numbers about productivity of employees in buildings, for example, at a building and after it's renovated to an NCEP, or different concepts are compared. So there are several studies out there from other areas. So if you can reach more productivity by employees by just 1%, it kind of gets back your payback duration of 20 years to 5 years, just by a little bit, let's say one productivity increase of the employees by working in a better NCEP office environment. The same is if you can reach a higher rental income with an NCEP by 3%, also the payback goes from 20 years to 12 years in the case we analyzed. And there are also some additional values like publicity values. So what would it cost if you have 10 press clippings in local newspapers, for example, that rise your publicity value? We found a method how to quantify that publicity value and implement it in a life cycle cost and income. The same is if you can rent out your building a little bit faster, for example, than a competitor that is not working on NCEP building. And also, what does it make for the health of the building if you have higher comfort, improved air quality, better materials? If you can reduce the sick leave by employees in an office buildings by 10%, also this payback calculation can be done differently. And what we try to do is to provide planners and investors with the tools and with the data to do those calculations based on case studies and previous studies. Back to you, David.
Yeah, thank you, Tobias. Finally, some general findings of our calculations. So what we have seen is, first of all, that the NCEP measures that were investigated only have a small percentage influence on the construction costs, but as we have seen, can reduce the CO2 emissions many times over. A result from the investigations and before, and what we have seen also in the presentations before, is that the cost reduction potential for NCEP technologies until 2050, they vary between 1 and 65%. So there are some technologies which have higher potentials, others have lowers. So in many cases, also what we have seen is that the return of investment of the energy efficiency measures is so to reach the NCEP target is around 25 to 40 years. This is often due to the co-benefits which are not included in the analysis. And if we do include the co-benefits in the analysis, then this return of investment is reduced, or the time for the return of investment is reduced. Furthermore, we have also seen that the cost optimum of primary energy and CO2 emissions is in the range of nearly zero and passive houses, and that the highly insulated envelopes and then also the high efficient windows are usually economical even without subsidies, and this is often due to this long service life of the elements. And finally, also that what I have shown also at the beginning of the results is that the cost optimum curve in relation to the CO2 emissions is very flat. That means low emissions can be achieved with the same or similar life cycle costs. So therefore, it's efficient to go also for low CO2 emissions. So that's it, mainly from my side, and thank you for your attention.
Okay, thank you, David, for the presentation. Now we go to the second session. Just a reminder, so all the questions you have asked in the chat will be answered after the second session. So the second session deals with the CRAVEzero pin board. So at the moment, a lot of methodology was shown, a lot of preliminary results were shown, and the concept of NCEP was tackled from different stakeholder perspectives and processes, technologies, business models, and cost reduction potentials. So one of the main results of the project is this CRAVEzero pin board. So what is the CRAVEzero pin board? So it's basically a structured web framework to build a low life cycle cost nearly zero energy building. And what will be happening in the second session now is really that is more like a hands-on approach. You can also, next to this webinar, you can try out the pin board by yourself. So you can access the pin board via pinboard.cravezero.eu, or you directly go to the website CRAVEzero.eu and click on the main banner of the website, and you will be directed to the CRAVEzero pin board. We will give you a general overview of the pin board, about the NCEP dashboard. Then Roberta Panetti from URAC will talk about the lifecycle cost calculation tool that is free to use. And Regina Höfler will talk about the NCEP process map, the NCEP process tracker. Sorry. And we will get an explanation about the NCEP business model canvas by Mr. Arnulf Dinkel from Fraunhofer ISE. So we will start the session in a minute. I will just stop sharing my screen and give you an overview of the pin board. So now I have switched to the web interface of the CRAVEzero pin board. I would like to welcome you to the second session on the webinar. As I said, this is a more hands-on approach. So you can find the address pinboard.cravezero.eu on top. Once again, a reminder to all the people who just joined, please don't forget to mute your microphone. There are always people who join and still have their microphone active. Please do that. So the CRAVEzero pin board, once you enter it, the structured framework, you find yourself in some kind of desktop version. So please be assured these are tools that are really free to use for everyone. There are also tutorial videos, help videos on how to use the pin board on YouTube, and some kind of explanatory PDF documents. When you come to the pin board, you also find some kind of guide that helps you through all the tools. So this is kind of a tooltip that gives you information of how to use the pin board. Basically, how does this pin board works? It consists of several modules that you can use separately. And you can reach those modules by clicking directly on the respective icons, or to use the menu to the left. Basically, the different tools deal with exactly the work packages or the topics that we have been talking about in the first session. There is a case study dashboard, parametric calculation of net zero energy buildings or nearly zero energy buildings, NCEP revenues, a business model canvas, process map, a database of costs that will be coming in hopefully the next 14 days, a lifecycle project management tool, a free-to-use lifecycle cost calculation tool, and 2 Excel tools that are downloadable and free to use. I will guide you a little bit through 2 of the first tools. One is based on the presentation of Mr. David Venus, this CRAVEzero case study dashboard. So you can access the tools by directly clicking on that. The interactive case study dashboard deals with the CRAVEzero front runner buildings. So it's about all the CRAVEzero cases from all over Europe and lifecycle costs and energy savings potential. So as with every tool, you can watch the tutorial video or go to the PDF manual or go to the dashboard directly. Once you, in this first tool, this CRAVEzero dashboard, you can select the case study you're interested in. I will do that for the case study Valagard from Skanska in Sweden. And here you can see what David Venus was talking about early on, and you can do this parametric calculation of the building on your own. It works in a way that you kind of reach the starting page. You can have some information about the building itself, and then you can kind of look for different variants. So you can change envelope qualities by just clicking on the respective icon, the compactness, the orientation, sea level, heating system, location, shading, window to wall area. And you can also look how the building behaves with different kind of user behavior. Because very often we found out the right technical solution set works, for example, for the standard user. But if you already know you have a not efficient user that wants to have higher temperatures inside, that has high, let's say, hot water demand, maybe doesn't ventilate the building like it is used to, another set of technical solution could be more robust, for example. So when I look at this first page, there are some parameters already selected. This is the reference variant, the so-called as-built variant. When you look at the results for this variant, you find yourself in the dashboard. It shows you the parameter selection from the first page here, and it shows you basically the whole parameter space. This is your selected variant with the parameters you had, and these are all possible variants of different sets of technological combination, different user behaviors that are theoretically possible in that building. On the x-axis, you can find the primary energy demand balanced because it considers all the imports and exports on electricity if there is a PV system, and the life cycle costs calculated over 40 years in euro per square meters. And this is plotted against each other. You can look for the reference variant, or you can show all possible variants. For most of the case studies, these are between 10,000 and 50,000 variants. You can access all of those different variants. And for each variant, you can also find with a tooltip exactly how that variant was composed. For example, this is a very good variant, for example, which has low life cycle costs and low primary energy demand. Whereas the variants on the upper end here are the variants that have high life cycle costs and a high primary energy demand. What is important is that most of the variants have really a quite high energy standard. So most of the variants are really going into nearly zero energy buildings, net zero energy buildings, and plus zero energy buildings. Since we all know that you can either come up with a conclusion by parameter selection, or you can look at the goals you would like to achieve using this slider. For example, you can filter variants that have, for example, low life cycle costs, and then you will immediately see the corresponding parameters. You can also say, okay, I want to look for the buildings that have, for example, low CO2 demand. You can filter the variants further and also filter your maximum amount you would be able to invest in the building. And then you find different corresponding parameters that are available or solution sets that are possible for your NZEP building that can be used. So it can be from a bottom-up approach. You select parameters, technical parameters for your NZEP building, or doing it by a top-down approach by just limiting the possible optimization goals like financing, life cycle costs, CO2, or primary energy demand. I'm going to show you also some more slides you can look at. You can also really go into detail about some energy benchmarking results for the different variants you have selected, or some life cycle cost benchmark results for all the case studies for all the parametric variants. So you can really look at life cycle costs, benchmarks, operating costs, net present value, investment costs for your variants, and can select and deselect them throughout the whole pinboard. And you can do this not only for this case study a la carte, but you can also do that for any CRAVEzero case study that is interesting for you, where you would like to try out. Also, there was a question before, for different case studies, different parameters have been analyzed. Some have a strong focus on technologies, others have a stronger focus, for example, on business models, or because I saw the question already from a participant, we also try to include from time to time is something like carbon tax. So you can also look at how would different case studies behave if there would be a carbon tax in 3 levels. So depending on how much euro per kilogram CO2 the building future carbon tax would be, you can also find out the optimal technical solution sets. So You can change the boundary conditions, also an energy price increase, usually user behavior and possible carbon taxes for different buildings. So you can do that with this interactive pin board. And what is interesting, this CRAVEzero pin board is one of the tools that can be used. And this kind of idea of this first dashboard tools of the front runner buildings is really to give you an overview of benchmarks, give you an overview of sensitivity of NCEP buildings, and give you an overview of how do different technical parameters, solution sets influence different outcomes, so that you can have more security in planning NCEPs. The second tool before we go to the second presentation is also what you can do is an NCEP revenue stream calculation tool. This is more from the perspective of investor of NCEPs. Again, you can have tutorials and PDFs. The revenue stream calculation, this is basically a payback calculator that works with a reference building, and it works with an NCEP variant. So you can kind of define your saleable, rentable area, expected year of sales, assumed property value, is it rental or self-occupied, some kind of energy-related parameters, and you can compare it to a high-quality building, an NCEP variant. You can tell them the additional costs, if there is funding, if there is a carbon tax that can be applied to the future, and added values that we discussed earlier. So do you expect a higher yield? Do you expect higher vacancy rate or reduced vacancy rate in your NCEP building, a higher rent, faster rental, additional, let's say, press clippings, so publicity value of the building compared to the reference building, and if it's an office, also increased productivity, staff turnover, and reduced sick leaves. Those numbers or percentages are difficult to quantify. In the reports we did in the project, we give you not exact numbers, but you can at least find a bandwidth what is likely to happen in such buildings, since co-benefits like increased productivity, for example, or reduced sick leaves are more difficult to quantify. You can also change global parameters for the calculation for office, for employee costs, discount rate, heating price, cooling price, things like this. And then interactively, you can calculate basically your payback calculation and you can work with, let's say, parameters like increased productivity. How would that change? For example, this is a huge lever, for example, for the payback calculation, or change your additional costs. And this works basically in real time. So you can do this investors calculation also in the pin board for new NCEP projects. For all the tools that will be explained now, it's possible to kind of have the input. Usually there is also a page with detailed results, so you can really find out what the tool does in the background, how is it calculated, how does it calculate those co-benefits. And what always works is that you can use the tools online as an interactive version. Let's say this is a version that is easy to do. You don't have to log in, you don't have to save data. Also, basically the inputs you do are not tracked. If you say, okay, I would like, this is a nice tool, but I would like to add further functionality, I would like to further develop that tool or to add certain parameters, you can always make a screen export for your client, or you can do also an Excel export. And then you will receive an Excel document out of this pinboard tools that is free to use. So it's not locked for usage, and you can further develop the tool, and you can use exactly that tool that you see on the pinboard as an Excel-based spreadsheet, where you have to reference the CRAVEzero consortium and have to inform us if you want to redevelop it, but it's basically free to use for everyone. So this was an explanation of, let's say, the first tools of the pinboard. So the first one really for planners, the second one more for the business model development or for investors. And now I will give over the presentation to our second presenter of the pinboard tools, Ms. Roberta Bernetti, who will talk to you a little bit about the lifecycle cost calculator, and both on an online version and this Excel tool that is possible to download. So Roberta will give you the the screen sharing opportunity. It will take a
Yes,
couple of minutes.
I'm going to share the content.
Yeah.
Okay.
So, yes,
I
you can
think
already
that now
see
you
your
can,
screen.
okay, you can see the pinboard.
Yes.
Okay, so concerning the life cycle cost tool, we developed two different versions. There is a first version that is it is possible to be downloaded. It is an Excel file where all the detailed calculation for evaluating the life cycle cost and drafting the NZ cost spreadsheet are implemented. So as Tobias shows before, basically you can access through the pinboard to the manual, the tutorial video, and you can download here the file that you can use for your project. Today, since the time is a bit tight, I will show you the online version that is a little bit more simplified than the downloadable Excel tool that is the life cycle cost calculator. It's quite quick. The breakdown of the building element is a little bit less detailed that the Excel tool, but in any case, it follows the CRAVEzero approach. So as for the other tool, here you have the manual, the tutorial, and you can go to the life cycle cost web tool. I already include some data just to show you the functionalities, but basically at the beginning you will see all the sections of the tool closed in this way. So you will you have to click on the box in order to display all the data to be included inside. So basically, as a general overview, you can compare two variants of calculation. So you have two similar masks where you can include your data. So as an example, I decided to put the same case, just changing some construction and service cost. So as you can see here, you have the first part with the main reference data. Then you can include the geometry data, so basically including the area, gross and net, the volume, again, gross and net, the treated floor area, the thermal envelope, and so you can also see your shape factor. Then you can put also here if you have some revenues from a monthly rent or the expected price for the building. To do this analysis, I would suggest to use the tool shown by Tobias before with the co-benefits, since it is very more detailed for including income coming from renting and selling the building, but also you can make some analysis here. Then you have a part related to the energy demand, when you can include different systems for heating and cooling, the production of domestic hot water, and for the production of PV. For each system, you can decide which is the energy source or vector used, and you can include here the related energy cost that is taken from here. So basically you can put here your cost according to your specificities, and also the estimated energy price increase according to your experience. Of course, if you want to include the data same that used for the CRAVEzero framework, you should go on the report, on the deliverable, and so you can put the same values as used within CRAVEzero. Coming a little bit up, Here we put a part relating to the building and to the building design and enabling costs. So you can put here the total cost for preliminary, definitive, executive design, the cost for the building site management, and some auxiliary costs for the purchase of the land and enabling cost. Here it's everything is free, so how can I say, you can decide if you would like to put here some values or not. And basically what is the important that you can calculate with this tool is to compare different variants. So if you want to understand the impact of the different phases here or different design and landing enabling cost and so on, you can fill in this part. If you don't have data about this part, the calculation would run in any case, so you can have your case. So here we are in the first section, project information. Then we go to the second section, construction cost. Just a remark, as you can see here, you can export an Excel, and also you can report of the screen. Coming to the construction part, basically here you can break down, so you can include here all the costs for the building elements. So you have the area, the unitary price cost, and here we include an impact and a price for the maintenance cost. Here you can find some default values, but you can clicking here and here you can change, you can modify the cost, and you have also the lifespan. The same story for the building services, and here you can choose among 80 different types of building services, so it's very detailed breakdown, and according to the kind of service you can also you have also here a different default maintenance. So basically maintenance impact. So basically, according to the choice, we included some reference value coming from the ISO standard 15459. Here we first so you have the life cycle cost in 40 years, the comparison between the two variants is a general overview with a chart. And then, very last information, an overview of the more detailed results. This is a very detailed breakdown. I hope that you can see it. Starting from the overall life cycle cost, here you have a breakdown starting from the operation, and then also including the design, construction, inside management, and again the breakdown for all the phases and all the contributions from energy and maintenance. Of course, this breakdown comes from your data, so the more accurate are your input data, the more accurate will be your results. But I think that this view can really give you the control of what are the main contribution within your project, and so which are the main costs that can be that you can work on to reduce the investment and the cost during the operation. And here also you have some other indicators that are also reported here, but you see also here the total cost and the cost normalized per square meter, dealing with the investment and the construction. And basically here you have all the main indicators that we identified also for the NZ cost spreadsheet. Here is the very last part that I would like to show you. You can also see here a breakdown of the different phases of the life cycle cost of the two variants that you have. Here And so also this is a quite good overview of the cost for your project. It's a very quick tool. You can also compare also only the cost of one building element or one service. So it's a very quick and rough, but it will provide you a good overview of your project. So that's just to make a quick overview of the results. Now I can stop sharing my screen and leave the floor to the next presentation.
Thank you very much, Roberta, for this introduction to the CRAVEzero Lifecycle Cost Calculator. So before we go to the next presentation, so as you know, this CRAVEzero Pinboard is a tool set of different tools that different offices or different partners are using, and we're sharing in this CRAVEzero project under one common framework. We have been dealing with the first tools about parametric design, front runners, NSEP revenues and co-benefits, and now lifecycle costs, very, let's say, technology based. Second thing that we also deal in the project is really about processes for NSEP. So do nearly zero energy or plus energy buildings need new processes, different processes than typical buildings, and business models. So the next presentation will be from Regina Höfler from IETech, who will give you an overview of the NSEP process map. And this is quite an extensive tool and a quite interesting approach on dealing with NSEPs with a more focus on life cycle processes. So Regina, you can share your screen. Okay. Yes, it seems to work.
Okay, great. Hello from my side. I'll give you a brief introduction of the process map, which you can find here on the dashboard. And you can open it by clicking on it. Yeah, here on this page, you can find a guideline where you can read how the process map works. You can also find here a button for a tutorial video, and you can also download the PDF manual. By clicking here on this button, you can go to the process map. And yeah, you will find this page by clicking on it. Here you can see the different steps of a process when it comes to a standard building. And here on this bar, you can find the different phases of a process when it comes to a building. Here, when you see the standard version of the process, you can find different steps, what you should do when it comes to planning a building. And here on this bar, you can just display some action items which are important to reach the goal of nearly zero energy building. So if you click here on this button, for example, for the action items for the owners and users of a building, you can find different actions right here, which you should implement on the different steps of the process. And here, if you click here on these actions, you will find just some explanations about the actions. When you close this again, you will come back to the whole planning process, and it also works with the action items for other stakeholders too. Another important part of the process map are some bottlenecks, which you can find here. When you click on these bottlenecks, you will get some information where you can expect maybe some bottlenecks. when it comes to the whole life cycle process. And here you can also get some information about the different bottlenecks. By clicking on it again, you can also fade them out again. When you click on the process here, there will also will be open an image where you can also download the whole process, and you can also print the process. Yeah, and as I already mentioned, here you can find the other process phases, and it's always the same scheme. So you can also find here some action items for different stakeholders. If you want to get more information, you can also click here, and therefore another page will open where you can find the whole deliverable, where the process map is implemented. Yeah, and by clicking here, you can go back to the pin board. Yeah, thank you for listening, and I'll give back to Tobias.
Thank you, Regina, for presentation of the process map. Based on the process map, there is also something that's called the lifecycle projectment tool. So it basically works with the same logic. The lifecycle projectment tool is a tool that we said, yeah, this might be necessary to not only know about the processes and actions that stakeholders have to do, but you also have to define who is going to do that action, to track the action, and to set deadlines for different actions throughout the life cycle. And this is why we came up with this CRAVEzero lifecycle management tool. It works also in a similar way. Basically, we have from urban planning, construction, and operations, so different life cycle phases. For each phase, there are different actions that we have defined. So in total, over the whole life cycle, there are really, let's say, approximately more than 80 actions that you can do. For example, not all the projects will require exactly the same actions. So what you can do when you start a phase, for example, the planning phase, you type in a date when this phase is going to be started, and you define what kind of things would you like to include. You say, I would like to optimize my building envelope. I would like to improve the window to door ratio and process, optimize insulation, for example, use photovoltaics, and think about airtightness and storage technologies. So I select those options that are important in the process. I have them. I can also, in this tool, kind of find out what is meant by this. So I can always find out a description of the action. Why is it important? What are the major difficulties? And are there any standards and regulations that I have to think about, or any further literature for each of the actions that I have selected? You will find that. And then you can basically make something like a Gantt chart out of it. You can say, okay, the optimization of the building envelope, the main driver or the lead should be, for example, the architect. Then I can define a start date of the action and a specific deadline. So I know as a coordinator of an EU project that this is quite important. And then for every action, you have to define, is it completed, is it pending, is it ongoing or delayed? So you can do that for all the actions and really use this tool as a, let's say, project management tool for your NCEP to guide along the process. So you define actions in a very early stage through the different phases. You assign main drivers. You also can define what is the quantitative and qualitative target you would like to achieve. Is it a high, middle, or a low target? You're interested in set dates, set deadlines, status, get an automatically generated Gantt chart that can be changed throughout the project. And this is something that we call a lifecycle management tool that can work alongside the process of an NCEP, and it can really track the NCEP from urban planning with different actions to planning, to construction, to operation phase with different actions in all the phases. Again, you can export the tool to Excel if you prefer an offline version of it, or you can make a screen export. And this process management tool is quite linked with the process map, whereas the process map, it's a tool to visualize the process and see the importance and the interconnections. The project management tool is more like a typical management tool with a specific focus on NCEP-specific actions and targets. So and now we come to the last tool, and the last tool will be the CRAVEzero business model canvas. And Mr. Arnulf Dinkel from Fraunhofer ISE will present to you the business model canvas. So one question to Arnulf. Arnulf, are you able to share your screen, or do you want me to do that for you? Yeah, it works perfectly. Arnulf, we can see your screen, but we can't hear you at the moment. Okay, Arnulf, we can't hear you at the moment.
Can you hear me?
Yes, now we can hear you.
Okay. So if you start the business model canvas, you see this page where you can get the information, the general ones about with PDF manual and videos, and the several steps are described what you can do within this tool. Model canvas itself, so it takes some time to change. Now you can see it. It's a copy of, it's an adaptation of the Osterwalder canvas with the several boxes of it. You can find first our business models we found with this list. You can choose one, for example, this one. You can find at the top where it is situated here, and you will find a link to a company who deals with this business model also. Then we have these several boxes. In the middle, you can find, for example, the value proposition and 4 questions for each box formulated here, where you can find the questions you have to answer if you want to create a new one. So there's the value proposition, there are customer relationships, customers, segments, then the strength and the key factors, so on. We have some definition on cost and on revenues. And on the bottom, you can find where it is situated within the stakeholders, and also again the life cycle phases. So this is for all these models you can find here. And of course, you have a print function of all of these models here. So it's a good starting point to deal with the business models. And of course, you can create your own one. Therefore, we have a second part of it here. So here you can create your own one. It's a blank one, and you can copy paste text from the existing ones we have in the business model here, and you put it here. And again, you will find all these questions here. Work on it, answer these questions, and create step by step your business model within this. And what is created here is the link to technologies or link to processes. So you can find these links here for this business model to the technology sets within the CRAVEzero project, and the link to the processes we already heard. So you land over there in the process, and you can go into detail in the process you will use, or at least with the revenues. So there was a part who's dealing with revenue streams for that, and you can use all this and put it together here. So you can create it, your own business model, play around. But of course, there are some limitations on that. So it's only more or less headline. If you want to go with the business model, it's not a finished one, of course. So it's a starting point with headlines, and you have to detail it more and more. And during our work, we found out that it's easier if you build a team within your company to discuss all these topics and to detail it further, and also how to existing business you always have at the moment now. At the end, you can print it out. It looks like this, so it's PDF, and it's not saved on the web, so it's your own model. You can play around and use it. So I don't know whether it's for the next session. Functionalities, I don't know. I think not, but you have to work on it. But if you open it again, it will stay there. So you can go back and forwards between these models and copy and paste something here and put it on your own. So it should be easy to use, I think, for you. So more or less, I would motivate you to use it, to implement it with companies or your offices, and so discuss it. It's worthwhile for everyone. Wherever you are on the life cycle phase, you can find ideas with that and play around with it. Thank you. Shall I give it back?
Tobias, you're muted, or at least I couldn't hear you.
Yeah.
Okay, can you hear me now?
Yeah. Yes.
Okay, now it works. Okay, thank you very much, Arnulf, and all the other presenters for your presentations of the pinboard tools. So I hope you're not overwhelmed at the moment. So I think a lot of information concerning the project, because it's really, it's a multi-stakeholder perspective over the life cycle with a lot of different tools and methods. I also posted for all of you the website address CRAVEzero.eu/reports. So as I said, there are 1,600 pages of different reports that really show you the detailed results of the work with all the tools, of the work with all the work packages, and there you can really find the detailed lessons learned and the detailed results of the project so far. As I said, it's still an ongoing project. And as also Arnulf mentioned, some functionality in the pinboard is still upcoming in the next months. So please be sure to always visit now and there. And also, if you use the tool, you find out some bugs, there is still a possibility to contact me via email when you find out some missing functionality bugs, so we can try to improve as the project develops further. Now it's the last part of the webinar, so we have exactly 10 minutes for a short Q&A session. So Benjamin Köhler collected some questions during the webinar. So Benjamin, maybe you would like to raise some questions from the audience.
Yes, I think we could start with a more general question, which is addressing actually all our reports and the tools which are developed. The question arose if it is possible to change the language of the reports and or tools. I think I can directly answer that. We discussed that several times in the project team. So far, we decided to only provide everything in English. But we are currently negotiating and working on possibilities to at least translate the pinboard and the online tools. For your information, all the Excel tools you can download for the pinboard, they're not protected. So actually, if you're interested in translating them on your own, you can do it if you want to apply them in your companies. Tobias, you want to add something to that?
Yes.
But, yeah.
Basically, this was a question also. Our colleagues from Bouygues are thinking about translating pinboard tools into French. If there is anybody interested in changing the tools into different languages, I think please get in contact with me. So basically, as Benjamin said, tools are freely available. You can translate them by yourself. At the moment, the tools are still in English. Yes.
Yeah. Tobias, I will also first raise the coming questions to you, which were raised during the presentation of the dashboard and the parametric analysis. There are 3 questions and I will directly read them out to you. The first question about was about the calculation of the energy consumption or where it comes from. Is there a simulation behind it? Then the second one is about the CO2 conversion factors which are used. If you can shortly say something about that. And this question was raised in the very end of your presentation about the dashboard, why ventilation systems are not included like heating. To be honest, I'm not sure exactly in which slide or which window of this of the dashboard this was raised, but probably you know.
Okay. Just very shortly. Usually for most of the buildings, the calculation behind the case studies are not national calculation standards, because we would wanted to have all the case studies comparable. So basically what is underlying under this parametric calculation is on the one side the life cycle cost calculation tool that we developed on the project. And for the energy calculations, it's done with PHPP with different climate data sets. So it's a PHPP calculation in the background. For the CO2 conversion factors, we used the CO2 conversion factors for the IPCC, so the International Panel of Climate Change. And concerning ventilation, different case studies, I think, have different technology options. There are several case studies, I think, that have also in the parametric calculation that have different ventilation systems, from window ventilation to mechanical ventilation to mixed ventilation systems. So it's really depending on the parametric dashboard on the case study you look at. There are several that also include the ventilation system.
All right, thank you, Tobias. I just want to add here that the parameters which are analyzed and displayed in the dashboard were negotiated and discussed with the different partners. So there might be some differences between the case studies themselves. Yeah. The next questions are going to Roberta. So it's about the life cycle costs. One question is about the base for the calculations. Are all calculations based on EU standards? If you could shortly say something about that.
Yeah. So as mentioned very quickly during the presentation, the base calculation follow the framework of the ISO standard, and in particular the ISO 15686. But this standard does not provide very detailed data on how to consider the maintenance cost, the interest cost. So there are no reference values. It's a good general framework, but it can bring to very different results, since the calculation really, this approach really leave a very large freedom, no? So for trying as much as possible to make the results comparable, and the calculation, and to reduce the uncertainties of the calculation, at least fixing some reference values and parameters, and for example also the time frame that is quite free also in the standard. We defined this more detailed framework. So basically that was our approach. We follow the general structure, but we go more in detail with defining the parameters and some specificity of the calculation in order to make it more replicable.
Thank you. And one more question also to you is about the usability of the LCC tool. And the question was addressing like the source of the parameters to be integrated there. Like, can the data be generated by the tools provided by the CRAVEzero consortium, or do you have to identify all the values on your own with like somewhere else separately?
So it depends on the kind of values. There are some values like, for example, the boundary conditions and the impact of the maintenance cost. for which we have already included some reference value in the tool. But on the other hand, concerning the cost of the construction of the services and so on, yeah, they should be based on the experience of the users. We will also make a cost database available. It will be shared in the Pinboard, as mentioned by the coordinator. And also that could be a reference for who that do not have information or details on the cost. But the tools are thought, so are meant to be used by someone that has already some ideas on the project, some idea on the cost of the elements and so on. And so it's a way to fine tune something that has been already set up.
All right, thank you, Roberta. One more question was now written to the chat. However, our planned time is already over. So my question to Mr. Weiss, if we have the time to answer the last question, or if you have to say something on your own now.
Maybe just one last question, and maybe for all the other questions that have been written, there will be, just because it was the question, you will get a follow-up link to this webinar with a video of the webinar, the presentation slides as PowerPoint, and the protocol where we answer your questions in the protocol itself in a written. But one more question would be possible, I think.
Okay, I think this goes to Roberta Pernetti and me, if I see it correctly. It's about the cost developments, the energy cost developments. Which one did we assume, and how sensitive are the results concerning this part?
Yeah, concerning the increasing of the energy cost, we selected a simplified approach. Basically, we defined a fixed value for the tool. I mean, for the tool purposes and for the tool calculation, a fixed value for each year. It is around 1.5%, and is taken from a statistical analysis from data available from different countries. Maybe for the sensitivity, Benjamin, you have more insight on that.
Well, there was a sensitivity analysis conducted in several work packages, so also on the parametric analysis. And what we also did was sensitivity analysis for the cost developments until 2050 for the technologies. And of course, like cost developments always strongly affect decisions and the results in the end. But the detailed results and descriptions of the sensitivity analysis can be found in the different reports. And as Mr. Weiss said, there will be a protocol afterwards, and we can add the links to the respective reports where it is described in detail to this.
Okay, so thank you, Benjamin, for your collection of the questions, and thank you everyone who joined the webinar. Thank you for your participation and for your interest in the topic. And thanks to all the presenters of the webinar and all the project partners. We will close the webinar now, so please be sure to look at the follow-up link of the webinar with some further information, and be sure to check on the website CRAVEzero.eu from time to time, since there will be some updates also in the next weeks and months as the project proceeds in the last year of the project. And if you have any further questions, don't fear to get in contact with one of the presenters directly. So thank you for your attention. Thank you for joining the webinar, and hopefully see you soon. Bye.
Yeah. Bye.
Bye.